Hi folks, we're going to take a look at number 8 from page 480. So they want us to find the Cartesian equation of a plane that contains this line and this point. Okay, so since we're looking for the Cartesian equation, it means that we need a point, of which we've got 2 easily, and we also need a normal vector. Okay, so that's the one we're going to have to do some work. So just to take a look at what we've got here, so say this represents the plane. So we've got a line on the plane. Okay, and I have a point, and I've got a direction vector, 1, 1, 4, and then I have my other point here, P, okay, which is the other given information on this plane. So in order to find a normal vector, I'm going to need 2 direction vectors, and then from there I can take the cross product to find a normal vector. So since this line is on the plane, it means its direction vector can be drawn on the plane. So there you go. I've got one direction vector for my line. For my plane, so 1, 1, 4. Okay. Now, in order to determine a second direction vector, well, what I can do is I can join the point on the line with that other given point. Okay. Now, the only thing I have to be careful for is to make sure that this point is not on the line itself, in which case I'd have a problem. But once I found that direction vector, well, it would end up being parallel to this one here. So we'll see what happens. So in order to find our second direction vector, I'm just going to connect these 2 points. Okay, so we've got 4 minus 2, negative 3 minus 3, and 2 minus 2. So that vector is going to be 2, negative 6, and 0. Okay, and in fact, since I can use any direction vector, so first of all I see it's not parallel to that first one, I might as well simplify it by dividing by 2. So this can be written as 1, negative 3, 0. Okay, so once I have these 2 direction vectors, I can take their cross product. Okay, so 1, 1, 4, and I'll write them one over the other. Okay, B prime there, which was 1, negative 3, 0. And this will make it easier to determine the cross product. So what do we have here? We have 0 plus 12. Okay, here we've got 4 minus 0, so 4. And here we have negative 3 minus 1, so negative 4. Okay, and what I can use as my normal vectors, I might as well use the simplified version. So any vector parallel to this cross product will work. So I might as well divide by 4. So I have 3, 1, negative 1. Okay, and so now I have all the information I need because I have a normal vector and I have 2 points I can choose from. So 2, 3, 2 seems a little easier, so I'll use that. So we take our normal vector, we take our point, and we put it into our general equation for a plane, which is ax, so 3 times 2, plus by, so 1 times 3, plus cz, so that's negative 1 times 2, and then plus the d value, which is what we're looking for. So d here is going to be equal to, well, 6 plus 3 is 9, minus 2 is 7. So we bring that to the other side, we get negative 7. And so now our final answer is just going to be 3x plus y minus z minus 7 equals 0. And there's our plane. Okay, so just a quick recap. First and foremost is to know what you need to find the particular equation you're looking for. So to find the Cartesian equation of a plane, we know we need a normal and a point. We had points, so that wasn't a problem. The work to be done was to find the normal vector, which we did by taking the cross product of 2 direction vectors. Okay, that's it for this one.